focus everything around that. Okay, so factoring and solving higher degree polynomials. Given, and either given a 0 or a factor is what we're going to be given. So I'm going to do number 1 together here. So f of x is equal to x to the 5th power minus 5x to the 3rd power minus 36x. And they're giving us that x plus 3 is a factor of that. Okay, so one thing that we can do here is not, and one thing I want to caution you about is don't forget all your rules of factoring anyway. Okay, that if we're asked to factor and solve something, then we still get all of those things that we did with factoring. So with this particular problem, if we're going to factor that polynomial, even though they tell us that x plus 3 is a factor, what else do we know because we're smart that that's a factor of that? Just by looking at the original problem. What do all 3 of them have? X. We know that there's a GCF. Don't forget that that exists. That can be a shortcut to helping you get a smaller problem to work with. Okay? Is this the number 1 that's on y'all's paper? No.
Our number 1 is x to the 4th minus 5x to the 3rd minus
Awesome.
plus 3x squared plus 15. I was so confused.
Let me just get one of y'all's and I'll work. Okay, sorry about that. Same ones. All right. Back up. Redo the writing on number 1. Maybe it's not all that stuff. That's got something better. Sorry about that, guys. Scrambling this morning to get everything together. All right. So this one does not have the. All right. It's all right. I apologize for the confusion. Okay. So here we do have a polynomial that doesn't have a GCF, but like I said, don't forget all your rules of factoring that you already know. So look for a GCF first. If there is one, you can make your job easier by factoring that out. Okay, because either a number that's in common, or if they all had the same letter, that's going to shorten your job later on if you can get a GCF out of it at the beginning. Okay, so look for that, even though they're giving us one of the factors. Since they gave us a factor and there's not a GCF across that entire problem, we can go ahead and jump to our synthetic division. Because that is a linear factor, x minus 3, the degree of that's 1, so that means we can do synthetic division. Remember doing synthetic division? We'd have a 1, -5, 3, 15, -18. Remember, we got to have a representative from every power of x, starting with x to the 4th for this one because it's the biggest, in descending order. And then what goes on the shelf out here?
3.
You said x minus 3 equals 0 and get 3. So 3 goes on the shelf out there. Okay. Now, synthetic division, drop the 1 down, multiply, add, multiply, add, multiply, add, multiply, and we get a remainder of 0. If you don't get a remainder of 0 there, so either you got a sign mistake, a mismultiplication, a misadd, or you messed up a spot somewhere. Okay, so we're dropping that 1 down, multiply, 1 times 3 is 3, add, that's -2. -2 times 3 is -6, add. Keep going across, and then we get a remainder of 0. They told us that x minus 3 was a factor of that, so that tells us, hey, I better get a 0 in the remainder. If I don't get 0 in the remainder, because they told me x minus 3 was a factor, then I must have done something wrong. Okay, that's what you're going to know. on all of these problems on the worksheet, okay, is that if I don't get a 0 in the remainder, I did something wrong. Now, here's what happens with that. It breaks down a polynomial that's fourth power how many times? How far does it go down? Well, we divided by an x to the first, so it's going to be x to the third. So this becomes x to the third minus 2x squared minus 3x plus 6. So what we're doing is we're factoring this polynomial. Here's the factor they told us about. Here's what was left. That was the quotient when we did the division. Now, how can I factor this the long set of parentheses here using my rules of factoring? Grouping, because it has how many terms? 4. So that's how I know to use grouping there. So if I group the first two together, what's the GCF of those first two? X squared minus, and then in parentheses, that'll be this x minus 2. And then what's the GCF of those second two? Minus 3. And gives us x minus 2. And then the factors for that are x minus 2 and x squared minus 3. And then the factor they told us about at the beginning was x minus 3. This is the factored form for that polynomial. Because x squared minus 3 is not a difference of squares. It won't factor any further. I can't go any further with that one. If it were x squared minus 4, hey, that factors as x plus 2 and x minus 2. But because it's 3, that's not a square number, so it's not a difference of squares, so I can't factor any further. Okay, so first step on every one of these problems is going to be that synthetic division. And then we're going to look at what's the quotient and see can we do something with that using one of our other rules of factoring that we know how. Okay, let's do number 3 together. See how it goes. X, this is the 5th degree, x to the 5th plus 5x to the 4th minus 15x cubed minus 75x squared plus 56x plus 280. And the factor they tell us about is x plus 5. So I'm looking for shortcuts if there are any, because that's a long problem, right? So shortcuts would be a GCF in the original problem. There isn't one for this one. Or if I knew some other way of factoring that first problem, the original problem, like if I could do grouping with it already, maybe I could try that. But synthetic division, if there's not a GCF, that should be your first step. Okay, so let's set up the synthetic division for this problem. What goes on the shelf for this one? -5. Just remember, it's going to flip the sign of that. Always going to be the opposite. So then we have 1, 5, -15, -75, 56, 208. Okay? So drop the 1 down. Go to multiply. Sorry. Is it 280? Not only am I... Thank you. That would definitely not get us a 0 in the remainder there. Thank you. All right, so 280 for the constant on the end. Sorry about that. All right, so drop the 1 down and go to work. 1 times -5 is -5. Happens to be a 0 right there. That's nice. So that's going to be 0, be -15. That's going to be -15 times 5. The 50 plus 25 is 75. Another 0. That's 56. 56 times 5, or times -5 would be -280, which is 0 as a remainder. So that leaves us the factors x plus 5. And then what's this going to be? X to the 4th power. Technically, it's plus 0x cubed, but we don't have to write that. I'm going to put minus 15x squared plus 56. So the zeros that are there, I'm dropping them away so that it looks like something I can do another method of factoring for. Okay. So for this one, what would be the method of factoring for x to the 4th minus 15x squared plus 56? X method. Even though it's not a quadratic, we can still do X method because it has 3 terms. So that's our other tool there. So 56 on top, negative 15 on the bottom. Multiply to be negative or positive 56 and add to be negative 15. Yeah, negative 7, negative 8. And my shortcut would be x squared minus 7, x squared minus 8. And there we have the factored form of that. I know x squared minus 7 won't factor further because that's not a difference of squares. X squared minus 8 is not a difference of squares. If one of those happen to be like an x squared minus 9, then that'll factor one more step with the difference of squares rules. Okay, so you're always looking for, once you get a factor done, look at the next piece and say, can I factor that? If you can't, then you're done. If you can, then you need to factor it further. You've got to factor it out completely out of that. There's the factored form on that. On the first, 15 there on that handout, all it's asking you to do is factor it, not solve it. The next 15 will go to the solving step. Okay, let's do number 5 then. F of x equal to x to the 5th power plus 2x to the 4th power minus 9x cubed minus 2x squared plus 8x. And they tell us that x minus 2 is a factor of that. I wrote it in parentheses for no apparent reason. Sure, I copied that right. X to the 5th, 2x to the 4th, negative 9x cubed, negative 2x squared, positive 8x, and that's it. Okay. What do we know about this one? It has a GCF of what? X. So I could go ahead and factor that out. Okay. Because I know it has a GCF of X, that's going to make my synthetic division a little smaller here. Because I'm going to take that X minus 2 and use synthetic division with this, with the X to the 4th factor that I've got there. So I've factored out the X because that makes my problem smaller. That makes it easier to do. So I'm going to set up my synthetic division with this longer parentheses piece to try to work out here. So set up the synthetic. 2 on the shelf, 1, 2, negative 9, negative 2, 8. And I get a 0 in my remainder, just like I'm supposed to. If you had done the synthetic division before you did the GCF, you still would have got a 0 in the remainder. The only catch would be that you would have to have a 0 at the end of your synthetic because of the missing constant. We're going to have a representative from every power of x. So you could do the synthetic at the beginning, but my suggestion would be look for that GCF and pull it out at the beginning because it just makes it easier at the end. All right, so now that leaves us factors of x, x minus 2, and then this is going to be x to the 3rd plus 4x squared minus 1x minus 4. So we factored a couple of factors out, and now we look to see, can we factor this long piece here? Grouping would be the method we need to try. So if I group that, the first two have a GCF of x squared, leaving x plus 4. What would I pull out of the second group? Minus 1, leaving x plus 4. So that's going to give us x, x minus 2. That's the 2 we already knew about. And then we have the x plus 4. And then we have an x squared minus 1. But what do we know about x squared minus 1? it's a difference of squares. So that means I could factor it as x plus 1 and x minus 1. And that is the completely factored form for number 5. Happened to be a 5th degree. We happen to have gotten 5 factors. That's not always the case. It wasn't on the others that we've done out of that. But that one factored out all the way and makes it really nice. Build that. Okay. How can you check to see if your factored form is correct, given the technology that you have in hand? You could multiply it all out if you wanted to. That's a little harder than what I was thinking. You could put a number in for x to both of them, make sure they came up with the same answer. That's also another way of doing it. Probably even harder than what I'm thinking. I got a graphing calculator. If I graph the first problem, the original, and then I graph this factored form, should they be the exact same graph? Yes. If there are any differences, then something's wrong with my factored form. Okay? So that's all 3 of those methods would be perfect ways to check your factoring, make sure you got the right factoring for the original problem. But I think the graphing part is just probably the quickest and easiest, even though it takes a little bit to type it in. If there's less probability of you making a mathematical error typing it in than there is if you doing otherwise. Okay. All right. Let's do number 6. F of x is equal to x to the 4th plus 2x cubed minus 64x minus 128. And the factor is x plus 2. X to the 4th, 2x cubed, negative 64x, and negative 128. Okay. Is there a GCF on that original problem? No. So I'm going to jump to the synthetic division. 1, 2, 0, negative 64, negative 128. Why did I put a 0 in there? Yeah, we're missing the x squared term. So got to have a representative from 4th power down. What goes on the shelf? Negative 2. Okay. Again, when they give you a factor, it's the opposite. When they give you a factor, it's the opposite. Okay? Now, drop the 1 down, run it through. There's a 0. Nice. X to the 0, negative 64. That's 128. That's going to work out the way I want it to. Absolutely wonderful. So my factors are x plus 2 and then x cubed minus 64. Well, what tools do I have to factor that x cubed minus 64? Difference of cubes. 64 is what cubed? 4. Okay. So remember, we're going to have a short piece and a long piece. What's the short piece for x cubed minus 4 cubed? X minus 4. Good job. And then the long piece plus 4x plus 16. And that's memorizing that pattern from the sums and differences of cubes. Now, I'll look to see if I can factor that long piece, but because it came from a difference of cubes, what do we know? It won't ever factor. If it comes from a difference of cubes, it's not going to factor. There is nothing that multiplies to be 16 that adds to be 4. We know that too. Okay? So even if you don't remember that fact, if you try the X method on it, it's not going to work. So that's the factored form for number 6. That is factored as far as you can factor it out of that. Okay? So first half here, we're just factoring, not doing any solving yet. So we're about to do some solving in a second. But the process, they give you a factor, set it up, look for a GCF first because that's going to make it a little easier later on if you get that out at the beginning, and then do synthetic division and then factor anything that's left. Okay, always look to factor further. Let's look at the solving part. Okay, so we're going to solve. Problems look almost the same. So when we look at number 16, f of x is equal to x to the fifth minus 9x to the fourth plus 24x cubed minus 20x squared. And then they give us a zero. What is a zero of a polynomial? It's another name for it. When we're dealing with quadratics, we talked about zeros. Another name for it was roots. What's another name for it? X-intercepts. Okay, so what they're telling us here is that this polynomial crosses the x-axis at 5. That's what they're telling us. Okay, they're using fancy terms like zeros and roots to tell us that, but that's what they're saying. Is that if we graph that, we'd see it crossing at 5, and that's going to relate to what we're going to do later this week. So understand that if you get a zero, it's where it crosses the x-axis. Okay, so we're taking 5, and we're going to use it like we did the factors in the first 4 examples we did. Okay. The only difference is it's an actual zero. It's not a factor. So when we set up our synthetic division, which we'll do in just a minute, we're not going to change the sign. They give us a zero, don't change the sign. They give you a factor, do change the sign. Okay? So don't change the sign when we do synthetic. Why am I going to wait to do synthetic on this one? Factors out a GCF of x squared. So if I pull out an x squared, that will leave me x to the third minus 9x squared plus 24x minus 20. And that's going to make my synthetic division a little easier to do because I don't have so many pieces. It's not quite as long. Because I'd have to put in a couple of zeros at the end if I didn't. I'll do that GCF there. Okay? All right, so synthetic division. Set it up. 1, negative 9, 24, negative 20. And then the 5 that they gave us is on the shelf. Okay? Run it through synthetic just the same way as you always have. So drop the 1 down and go to work. 5, negative 4, negative 20, 4, positive 20, 0. So now the factors are x squared that I pulled out at the beginning. What's the factor for the 5? X minus 5. That was that factor. And then what's left here is x squared minus 4x plus 4. Can I factor x squared minus 4x plus 4? Well, what method would I use? X method. So I'm going to try that. So 4 on top, negative 4 on the bottom. Multiply to be positive 4, add to be negative 4. Negative 2, negative 2. So that means it does factor as x minus 2 and x minus 2. Now, we've got the factoring done. Once you get the factoring done, that makes the solving super easy. Okay? If we're going to find the zeros of a polynomial, the x-intercepts of a polynomial, how did I find the x-intercepts of a polynomial or a quadratic? I set the problem equal to 0. I'm going to set this whole thing equal to 0. So that's going to be 0 equals x squared, x minus 5, x minus 2, and then another x minus 2. The rules for when it's already factored, what do you do with each factor? Set it individually equal to 0. So we have x squared is equal to 0. We have x minus 5 equal to 0. We have x minus 2 equal to 0. The other one's the same thing, right? So there's no sense in setting another one equal to 0. It's going to give it the same answer. Okay, so what squared gives me 0? 0. So x equals 0. This one's going to be x equals 5. We knew that one already. They gave it to us at the beginning, right? That x should be equal to 5. That should be a 0, this polynomial. This is going to be x equals 2. The difference is going to be that 0 has what's called a multiplicity of 2. And x minus 2, that factor appeared twice, right? So it has a multiplicity of 2. We have 3 different answers. The 0 has a multiplicity of 2 because it came from x squared, right? The 2 has a multiplicity of 2 because how many times did it happen? Twice in the problem. We had x minus 2 twice as the factors. So we get a multiplicity based off of that. Multiplicity is how many times does it occur? X squared equals to 0. Well, that's x equals 0 twice. That's what that means. Okay. All right. So factoring the same way we're doing the first half of the handout, and then last step, the solving, set all your factors equal to 0, and work them from there. Okay. Let's look at 17. Got f of x is equal to x to the 4th minus 2x cubed minus 12x squared minus 6x minus 45. And then they tell us that the 0 is 5 on this one as well. Is there a GCF on this one? No. So that means we go straight to our synthetic. 5 goes on the shelf. 1, negative 2, negative 12, negative 6, negative 45. Run that through there. There I get 0 on the remainder, just like I would expect to, because I'm doing synthetic division. They told me 5 was a 0. That means I better get 0 on the remainder. Now, we got a factor of x minus 5. And then we've got x squared x cubed plus 3x squared plus 3x plus 9. What method could I use to try to factor that? Grouping. So the first ones have x squared in common. Second ones have 3 in common. So the factored form is x minus 5. That's the one that they told us about. And then we have x plus 3 and x squared plus 3. Will x squared plus 3 factor any further? No. To find the zeros of that, I set that thing equal to 0. I get x minus 5 equals 0, x plus 3 equals 0, x squared plus 3 equals 0, and I solve each of those. X equals 5, x equals negative 3. Those two are easy. The last one's a little bit more difficult, but we've solved a quadratics like that before. How do we solve that? What's one option?
Move the 3 over.
Yeah, I can move the 3 over. Yeah, subtraction. So x squared is equal to negative 3. And then I would take the square root. And on the side with the number, got to put the plus and minus. So plus or minus. And then because it's a negative, it'd be I radical 3. Remember, 3 doesn't have a square root. That's nice, so we're going to leave it in there. So plus or minus I radical 3. So we have how many solutions or zeros or roots or x-intercepts do we have? Well, I'm going to say x-intercepts. We got 4 answers, right? We got 1, 2. The positive I radical 3 is the third one. The negative I radical 3 is the fourth one. What was the degree of the beginning? They're always going to match. Yes, ma'am. It's always going to work that way. If we go back to the previous problem where we had all these, 0 counted twice, right? That's that multiplicity thing. And then the 5, that was the third one. And then the 2 counted 2 more times. And the original problem had x to the 5th power at the beginning. So it's always going to total up to be.
That's kind of how I was checking them yesterday when I did my answers, but I was making sure I had to measure them.
No, that's absolutely correct. That always goes together. Thing called the fundamental theorem of algebra that makes that work. Not that you necessarily need to know that that's what it's called, but that's what it does. Let's do this one. X to the 4th minus 6x cubed plus 5x squared plus 12x. And they tell us that 3 is a 0 of that polynomial. What do we know about this one? I can pull out an x, the x cubed minus 6x squared, 5x plus 12. That makes it a little easier to do the synthetic division with the 3. 1, negative 6, 5, 12. All right, so drop the 1 and go to work. 3, so that's negative 3, negative 9, 4, that's negative 12. And there I get the 0 in the remainder, just like I'd hoped I would. And so now my factors are x, the GCF I pulled out at the beginning, x minus 3 for the 0 they told me about, and then I have x squared minus 3x minus 4. And I would try to factor that. How does that factor? Or will it factor? Forget what method would I even try? X method, so negative 4 add to be negative 3. Negative 4 and 1. Good job. So that's x minus 4, x plus 1. And I have x minus 3 that I already had, and the x that I already had. I'm taking that and setting it equal to 0 to find the solutions, the x-intercepts, the zeros, the roots of this polynomial. Okay, so I get x equals 0, x minus 3 equals 0, x minus 4 equals 0, and x plus 1 equals 0. So I'm just taking each factor after I've factored as far as I can, taking each one of those to set it equal to 0 and solving it in whatever way. So this one, done. This one we already knew. This one, not much more work to that. 1, 2, 3, 4 of them. The original problem had x to the 4th power. If you were to graph the original problem, you would see it crossing the x-axis at all 4 of those places, because that's what we're finding here, the x-intercepts. Okay. Yeah, somewhere show me the factored form, whether it's where you're setting it equal to 0 and then show me your solutions after you've solved them. Somewhere I need to see that factored form so I can see, hey, if we made a mistake, it's probably in that factoring. Most likely not going to be in the solving part, because you guys can handle that part. It's the factoring part that's the hard part here. But so I would hope to see the factoring portion somewhere out of that. Let's do one more. X to the 4th minus 3x cubed plus 64x minus 192. And 3 is a 0 of that polynomial. All right. So go ahead and do synthetic division, right? Because there's no GCF. 1, negative 3, 64, negative 192. What else goes in there? 0 for the x squareds. If you don't put that in there, you're going to run into an issue. Looks like at some point. All right, run that through with synthetic. 1, so there's 3. There's a 0, and that's 0 again, and then 0 again. This looks familiar. 3 times 60 is 180, plus 12 is 192. And there's the 0 in the remainder, which is what we were looking for. So our factor would be x minus 3 for that piece, and then x cubed plus 64. Okay, so that's similar to what we've done already. This is a sum instead of a difference. This is a sum of cubes. So that's 4 cubed. So our sum of cubes has a short piece and a long piece. What's the short piece? Good job. The long piece. Good job. Again, that's the pattern we memorized for the sum and difference of cubes. That the short piece is always the same sign, and then it's opposite in the middle of the long piece. Now, what do we know about that long piece as far as factoring goes? You can't factor it, okay? So that's where we run into a little issue when we go to solve this. When we set it equal to 0, yeah, I can set x minus 3 equal to 0 and get x equals 3, the one we already knew about, and then x plus 4 equal to 0, and I get x equals negative 4. But when I have this one, when I set that equal to 0, it doesn't factor. So how else can I solve that? Say it again. Quadratic formula, right? X equals negative b plus or minus radical b squared minus 4ac divided by 2. So, don't know that. You might want to know that. So that quadratic there, we're going to solve by quadratic formula. So b squared minus 4ac, negative 4 squared minus 4 times 1 times 16. Be 16 minus 64, right? And that'd be negative 48. And so we have x equals negative b, so that'd be 4 plus or minus the square root of negative 48 over 2. Well, I need to break down the negative 48. You know, factor tree, simplify that radical. 12 and 4. 4 is 2 and 2. 12 is 6 and 2. 3 and 2. So 1. 2 pairs of 2's. So that's going to be x equals 4 plus or minus 4i radical 3 over 2. And then I can simplify that because 4, 4, and 2 are all divisible by 2. So I can rewrite that as 2 plus or minus 2i radical 3. And the 2 on the bottom is canceling itself out. So this one has 4 answers. 3, negative 4, 2 plus 2i radical 3, and 2 minus 2i radical 3. Still 4 answers. The original problem had an x to the 4th power. So we're still the same there. Now, if you were to graph this one, it would only cross the x-axis in 2 places, not 4, because these are complex solutions. The complex solutions don't cross the x-axis. That's why they're called, they kind of have that name, because they don't show up when you graph the thing. Okay? The imaginary part messes that up. Okay. These problems are not short. You know, here we've done 8 of them, and it's taken a good bit of the period. These are not short problems, and I don't expect you to rush through them. So you're not going to be as fast at it as I am. Some of you are not. Some of you you're good at this. You know how to factor. You know how to do synthetic division. So you're going to be okay. So the idea here is that you're working on this. You got a little bit of time left today, about 20 minutes, and then you got tomorrow to work on this as well. Okay, so there's 22 other problems to do on here. again, the top half, you're just factoring. The second half, you're factoring and solving. Okay, so that's what we're doing here. Factoring on the top, factoring and solving on the bottom.